partial differential using Lagrange's form or using by integration method. So now today, actually, there are two different types of solution of PDE. One is non-linear PDE, another one is linear PDE. Linear PDE solution we have done, that is over. Now again we have non-linear partial differential equation of first order, the solution. So for this one, what we are doing here is we are going to divide this PDE, non-linear PDE, into different forms. Standard form 1, standard form 2, standard form 3, standard form 4. Okay, and the problem which are not able to solve with any one of the standard form, that is solved by Charpit methods. So we cannot start Charpit method immediately. You can get the idea of these standard forms, then only we can go for Charpit methods. I think I sent one video, you can see in there. I shown already how the standard forms and how to go for Charpits. So let us start with the standard form 1. Today we can discuss the standard form 1. What is the standard form? What is the working rule? And how to solve the problem. Then we can go for a standard form 2, working rule and problem. 3, working rule, problem. 4, working rule, problem. After completion of all these things, we can go for Charpit methods. Then finally, we have to write the complementary function and particular integral for this partial differential equation, and this unit will be completed. Okay?
Yeah.
Let's start now. Standard form 1. Standard form 1. So the partial differential equation of this form, f of p comma q is equal to 0, which has only p terms and q terms, no more x, y and z terms. If there are x, y, z terms, by using a suitable substitution we have to eliminate that. So any differential equation, any partial differential equation of the form p and q, where p and q are the only terms there in that form, such a form is called standard form 1. Now we can see how the working rule, how to solve if our question is in standard form 1. For this one, you can see the working rule. Working rule for standard form 1.
In first chapter, I only have partial differential equation of first order, right?
Yeah. Second unit, you have partial differential equation of higher order. There you have to study about wave equation, heat equation, classification. That will be there in the second unit.
Okay.
First unit, first order. Second unit, higher order.
Yeah.
Okay. Now you see what is the working rule. Now consider the complete we can say complete integral or complete solution. Choice is yours, you can say anything. Complete integral of 1. Consider the complete integral of 1. Means we are assuming the solution of the equation number 1. This is our equation number 1. Okay, complete solution of equation number 1. This form we are assuming. Z is equal to ax plus by plus c. Ax plus by plus c, where this a comma b and c are the arbitrary constants. Arbitrary constant means which we can easily eliminate. Okay, that is called arbitrary constants. Now you take this the equation number 2. Now if I want to differentiate equation number 2 partially with respect to x, what is your answer? Tell me. Differentiate equation number 2 partially with respect to p. What is your answer? Tell me. Not p, with respect to x we do. With
Yeah.
respect to x, we can do it. So what's the answer? Dou z by dou x is equals to, if I'm differentiating this one with respect to x, x becomes 1, only a left off, correct?
Yes.
And this is no x term 0, this is no x term 0. And already we know that dou z by dou x value is p. So it means our p value is what? A.
A.
Similarly, if I'm differentiating the same equation number 2, partially with respect to y, partially with respect to y. Now what's your answer? Dou z by dou y
Dou z by dou y equals to
is
D.
equals to b only. But already we know that dou z by dou y value is q.
Q.
So we got a value, sorry, p value and q value. So these two
Yes.
values we have to substitute in equation number 1. Substitute in 1.
Yes.
If you substitute these values in equation number 1, our equation number 1 reduces to f of a comma b is equal to 0. Correct? Which implies
Yes.
we can use this relation and we can get the value of b should be in terms of a. I want to write
Yeah.
in terms of a in a function form. So we get one relation between a and b. Using that relation, we can find out the value of b in terms of a. And then finally, this b value, okay, we have to substitute in second equation. B value we have to substitute in second equation. Then what is this z becomes? Z is equal to a is a only, ax plus p value is what? Phi of a into y plus
Yeah.
c is equal to 0. And this is called the complete solution or complete integral of equation number 1. This process we have to adopt every time. Now see some questions. We can go to the questions directly. Some questions I'll take it. Some 4 to 5 problems I will solve it. So then you will get the idea what is nonlinear PDE and how to solve it. Then standard form 2, 3, 4. Then sharp it. Question number 1. Only it is given to solve. Solve P plus Q is equals to 1. Can you say that it is in standard form 1? What I
Yeah.
what I said is standard form 1 means it should have the terms of P and Q only. Okay.
Yes.
So our question is in terms of P and Q only. Now we can start writing their solution. Solution. First step is this is short answer only. This is short answer. It is not a long answer. Given PDE is partial differential equation is P plus Q is equals to 1. Call it as equation number 1. Okay. What is the process? Let the complete solution or complete solution of 1 is how to take? Can you tell me how to take? Z is equal to
Z equals to
ax
P
ax
X plus
p
PY plus C.
plus c. This is taken as equation number 2. Now if you differentiate z value partially with respect to x, what is the answer? A. And already we have shown this is in the process also. P value is A, right?
Yeah.
Dou z by dou y. Differentiating z value with respect to y. Then answer is B. This is called Q. Q is equals to B. So after getting the values of A and B, we have to use in equation number 1. Substitute in equation number 1. So our equation number 1 reduces to p value is a plus b is equal to 1. What I said, I'll get the value. I will get a plus b value with the help of some relation. From this relation, we can easily get the value of b, which is in terms of a.
Yeah.
It is minus a. Okay.
Yes.
Then after this one, this value of b, we have to substitute in equation number 2. Substitute in 2. Then what is z becomes? Ax is ax only, no change here. So this is ax only plus b value is 1 minus a into y plus c. This is called the complete solution of equation number 1. That's it. This much only.
So we have to basically eliminate the b term so that we get
Yes.
all the values in a.
Yes. Let me take one more question. I will do it so many questions till you understand the concept. We'll do it. Question number 2 we can take. Question number 2. Solve t plus sine q is equal to this.
In standard form 1, we will only get the question in the form of p and q, only
Yes,
these variables.
of course. It should be in terms of p and q only. If p, q and z involved means standard form 2. P, Q, Z, X involved, X and Y involved means standard form 3. Like that.
Yeah.
Now given PDE is partial differential equation is P plus sine of Q, sine Q is equal to 0. It is equation number 1. So let the complete integral of 1. Complete integral भी लिख सकते हैं. Your choice is there. You can write either integral or solution. Integral of 1 is, how to take that? Tell me. Z is equal to
ax plus by plus c.
ax plus by plus. You have not discussed this type of question in your college? Standard form question?
We did.
Yes. Dou z by dou p is equals to, if you differentiate partially, you will get a, which means that the value of p is equal to a. Every time the process will be same. Dou z by
dou x.
dou, oh sorry, writing mistake it is. Sorry for that, it's a writing mistake. Which implies p is equals to a, comma, dou z by dou y is equals to b, which implies that we can say q is equals to b. Substituting a, these two values p and q in 1. So if you substitute equation number 1, reduces to, what happens? P is what? A plus sine of q value is b is equal to 0, which implies that sine b is equal to minus a. This implies that b value is equal to, sine will go that side, it is becomes sine inverse of minus a. After getting these values of b, we have to substitute in our equation number 2. Then equation number 2, our complete integral will become ax plus b value. B value should be in terms of a only. Sine inverse of minus a y of y and plus c. That's it. This is called the complete integral of the standard form 1. I'm giving you one question and waiting for your answer. Let me do it. Can you do it this one? The question is solve. Solve. Take a paper and just do it. PQ is equals to 1. Just tell me the complete integral answer, direct answer.
Dou z by dou x will be
No, direct answer. No need that. I want this step direct. Z answer, complete integral I want.
ax plus 1 by a y plus c.
Yeah, correct. Correct. So directly I'm writing Z is equals to answer is ax plus 1 by a of y plus c is the complete integral of the given equation number 1. Okay, just 1 second. Here only will write ax plus 1 by a of y plus c. Now look at, we can go for next question. Next question is, the next question will be, you have to solve this equation. But this time I will tell you something. I'm taking something different question. Solve. The question is p square plus q square is equals to n p q. This is your question. Now I want to solve it this one. The solution is given partial differential equation is p square plus q square is equals to n p q. It's a 1. Equation number 1. What is the next step? Tell me. Let the complete integral, let the complete integral of 1 is, what do you say? Z is equals to ax plus by plus c. 1 second. Message आया Yes. So after that, what we have to do? We have to differentiate the value of z partially with respect to
X.
x. So the answer will be equal to a, which implies that we can say z value is p. So p is equals to a.
Every time we will get the value of P as A only and Q as B.
Yes, yes, yes. This is the process. In
Okay.
second method also, second standard form 2 also, every time we have to write the process. Every time this is same.
Yeah.
If you are perfect in this all standard forms now, you can easily do it Charpit methods. And the
Okay.
question maximum will come from the Charpit methods only. These are the short answers. That is your long answer. So getting
Okay.
A and B value, Z becomes where we are substituting, not here. We are substituting in 1 now. 1 implies that P square means what? A square plus B square is equal to what we are getting? N P Q. Now I want to get the value of B now. So let me take
Yeah.
B as a subject. So what we'll do? Can I write like this? B square minus NPQ.
On the other side, on the right hand side, we will not put the values of P and Q.
Oh, sorry. मेरा ध्यान किसी तरफ है. I'm just taking the phone. AB. I'm sorry for that. B square minus NAB plus A square equal to 0. Can we write like this?
Yeah.
B square minus NAB plus A square. So what I want to do it, B square as it is plus, it's a minus NA into B plus A square is equal to 0. Can we write like this? Because what I want to do it, I want to solve this one as a quadratic expression form. I want to compare this in a standard form. AB square, not AB square, AX square plus BX plus C is equal to 0. Want to convert into the quadratic form. So then A value is 1. Actually, our equation is in a quadratic form in terms of B. Okay. So the B value is minus NA. And the C value, of course, A square only. Okay.
Yes.
So
Yeah.
you know the process. So converting into the quadratic form and then solving minus B
Yes.
plus minus under root B square minus 4AC by 2A formula.
Yeah.
Use that formula. Use that formula and solve it. So question is B square plus minus NA times B plus A square is equal to 0. You can see here we got the values of ABC. A is 1, B is minus NA, C is minus A square. So then I want to write the formula. We are writing in terms of B. B is equal to, better to use another color. B is equals to, what's the formula? Minus B plus minus under root B square minus 4AC by 2A. Actually, X will come here. X will come here, but we are writing the solution in terms of B. That's what I am writing
Yeah.
B. Actually, X will come here. B is equal to B value. B value is minus of minus A. Correct? Because
Yeah.
you see in the previous page, B value is what? Minus NA. So I want to write minus of minus B. Why 2 minus Y will come? Just 1 second. Okay, correct. Plus or minus under root B square. B square means N square, A square.
Minus N.
Minus
N
we have to
square.
make it a square.
Yeah.
Minus we have to make it a square. A is 1.
4,
C value
1
is
into A square.
C value is a square. That also I want to write clearly. This is a square by 2 into a is 1. So this is b is equals to minus into minus plus na plus or minus. From these two, can we take a square common?
Yeah.
A square should be out of the root, will become a only. And inside under the root, what's left of? N square minus 4 by 2. Correct? Shall we take a common? A common. A by 2 into n plus minus under root n square minus 4. It is actually the value of b, which is in terms of a. It
Yeah.
is the value of b in terms of a. After getting the values of this b, we have to substitute in equation number 1 and you will get the complete integral. Substitute in 2. So z is equal to ax only plus b value. B value is a by 2 into n plus or minus under root n square minus 4, okay, of y plus c is the final answer.
Yeah.
This is the way to find out the complete integral using standard form 1. Okay.
Yeah.
Now I'm giving you one question again. You have to try that question. Number 4. 4 only, no?
Yeah.
The question is p square minus q square is equal to 1. Just solve this one and tell me the answer. Direct answer.
Is z equals to ax plus a square minus 1y plus c?
Are you not getting plus or minus?
No.
Actually, the answer will be this. This is the answer. Z is equal to ax plus or minus root of a square minus 1 of y plus c. Because if you want to find the value of b square, should be plus or minus only, no?
Yeah, b square I got is
Your answer is like that. A square plus b square is equal to 1. correct?
Yeah.
Which means b square
Minus
value is what? 1 minus a square, right?
Yeah.
1 minus a square. Here
It is actually a
yeah,
square minus b square
yes,
equals to 1.
b is equals to plus minus under root 1 minus a square. Yes, correct. So it will come here 1 minus a square. But I want to talk about plus or minus actually.
Yeah.
Plus or minus you have to write compulsory, right?
Okay. Uh-huh.
Okay. Try one more question. The question is p square plus q square is equal to 9. हेलो इकबाल आओ ऊपर आओ.
So I got ax plus or minus under root 3 minus a into 3 plus a whole into y plus c.
Okay, see what is the answer here. I'll show you. What is you got it? Actually, the answer is this one. Z is equals to ax plus under root of plus or minus no
Yeah, plus or
plus
minus.
or minus under root of 9 minus a square of
Yeah.
y plus c. Are you getting the same thing?
Yeah, actually what I did was halfway through the problem I wrote 9 as 3 square because already I have a square. So to convert it into the formula, I wrote that.
No problem.
But I can.
That you can write either 3 square or 9. Both are accepted.
Okay.
So this is standard form 1 we have discussed today. Maybe
Yeah.
the standard form 2 is very small only. Together also we can do it. Let us see what will be the situation. But anyhow, I want to stop now. Standard form 2 will be the next class.
Okay.
I'll send this recording to you. Thank you.
Yeah.